Now, having just done the activity that we just did, this actually looks very similar to that because we've got sine of something and cosine of something. Now, actually, it doesn't fall into that category at all because actually we have the same number of x's here, where on the other formula we had a and b, which can actually be different items. Now, for this one, this is very close to this question. So if I do a half times 2, that just gives me 1, so that doesn't actually change the question at all. But there's a reason why I've done that, and it's because this is an identity, which is what we're really trying to do with all of these questions. We're trying to make them into something that we know how to integrate. So this is the identity from your formula sheet for sine 2x. Therefore, when you integrate this, the integral for sine is negative cosine of the same thing, but then divided by the differential of this, which would be 2. Of course, don't forget to put plus c on the end. So actually our answer for this is negative cosine 2x over 4 plus c. And possibly if you look in the back of the book, you might find a slightly different answer, because also there's identities for cosine 2x that we could substitute in there as well. Now, if we make this question slightly more difficult, so if we were to go with something like 6 sine 2x cosine 2x, then it's the same sort of idea. What we're trying to leave here is 2 sine of something. So at the start of the question, I'll need to put a 3, because 3 times 2 equals this. And then it's the same sort of idea. So our formula that we know is that sine 2x equals 2 sine x cosine x. But notice in our question, the one we're doing here, we've got 2x rather than x. So actually we doubled each of these values. So we'll need to double this as well. So wherever we see x, we need to substitute in 2x. So 2 times 2x actually gives us 4x. So this integral turns into 3 times the integral of sine 4x, and then it's the same as before. The integral of sine is negative cosine over the original, or over the derivative I should say, plus c, and then when we bring the negative to the front, we get negative 3/4 cosine 4x plus c.